Hey guys, welcome back. This is Amir Sheikh, Faculty of Chemistry, and today we will learn some important reactions in the organic chemistry from letter A. So we will discuss some specific reactions that are very important regarding this competitive exams or UG and as well as PG. So welcome you all in this lecture. So first of all, the reactions are how to remember this name reaction. There are what many reactions are there, so it's difficult to memorize that all reactions at a time. So there are some ways to identify or recall or memorize that reactions are. First, each and every name reactions should have the some specificities. So for example, for each reactions you must have specific target molecules, which molecule will be prepared, what are the specific reagents which are used in this reaction, and most importantly what are the reacting species. So for every reactions, so first is reacting species, second is reagent, and third is a product. What will the product will be formed. Then second part of this reaction is mechanistic approach, how to understand the mechanism, and there are some related examples. We'll start first name reaction. So this name reactions having 5 specific portions. First is a statement of a reaction, that is one can call definitions. Then second part is what type of reactants which are used, and condition, whether it is acidic condition, basic conditions, or in neutral conditions. Okay, this is the second part. Third is a product, what will the product form in this reaction, and most important the mechanism of this reaction. These are the 3 important parts of what every name reaction. If stereochemist is given, EZ formation, 3O erythro, or any stereomeric relationship is there, so must be mentioned in the reaction and related to some examples. So these are the 5 points. Okay, first 3 are very important for each and every name reaction. Every name reaction is differ from each other by 3 or these 5 concepts. Okay, let's see the first reaction, that is called as a letter A, that is Acyloin condensation reaction. What is that Acyloin? Acyloin is a functional group or is a bifunctional molecule having OH, that is hydroxyl group, and carbonyl group, they are adjacent to each other. So this molecule is called as a alpha hydroxy carbonyl group. It is an aliphatic molecule, aliphatic compound. Alpha hydroxy carbonyl group is called as a acyloin. Instead of that alkyl group, or if you replace that alkyl group with benzene or aromatic ring, then that molecule is called as a benzoin. You know that benzoin condensation is a well-known reaction. Okay, and that is also be called as alpha hydroxy carbonyl. But the difference is one, in this benzoin there is aromatic skeleton is there, while in case of acylene there is a aliphatic skeleton is there. Okay, what is the statement of this reaction? So very simple again, it is a type of a reductive coupling of a 2 ester molecule. There are 2 ester molecules are there. Okay, and that's why this reaction is inter as well as intramolecular, and these 2 ester molecules are coupled together in the presence of what metal, for example sodium, and that will be converts into the what alpha hydroxy ketone. So that reaction is called as a Acyloin condensation reaction, or simply Acyloin reaction. Now here the reaction scheme is given. 2 ester molecules are treated in the presence of what sodium as a metal, so there is a reductive coupling is occurred, or electron transfer process occurred, and formation of alpha hydroxy carbonyl compound. Let's see the mechanism of this. You know that sodium is a reactive metal used for single electron transfer. The 1 electron from sodium will be transferred to carbonyl carbon. You know that the pi bond will be cleaved and there is a formation of radical anion. Now there is a one limitation is there for this reaction. So that radical can easily couple with other radicals, so there is a formation of pinacol also. Okay, so now in this mechanism, in this reaction, what happened with this now? Actually there are total 4 sodium are used, that is 4 electron transfer reaction is this. Firstly what the ester will be converts into the radical anion. So look at this reaction where sodium is treated with the carbonyl carbon. So 1 electron transfer will be takes place. Okay, and 2 ester molecule will be simultaneously converts into the radical anion. Second step is that these 2 radicals are combined together, so there is a formation of carbon-carbon bond. So this is the second step of this reaction. and you know that, so alkoxy group, that is OR, is a good leaving group. So first step is when this O negative, that is oxygen electron, will be restored, OR will be free. Okay, so first OR will be free, in the second step second OR will be free. So likewise you can get the molecule where both what OR will be free, and there is a formation of 1,2 dicarbonyl compound. 1,2 dicarbonyl compound again treated with the 2 equivalent of sodium, that will be converts into the biradical molecule along with the anion. Okay, so this is the biradical anion. So then what happened with this now, particularly this carbon carbon radical will be formed a double bond, or coupling will be takes place, and that O negative Na plus ion, that will be protonated, or one can call it acidic workup, or simple word protonated, takes place in the presence of water, that will be formed at the vinylic diol. Okay, and you know that diol undergo the tautomerism, and one of the OH, one of the hydroxy group will be converts into the carbonate. So there is a formation of alpha hydroxy carbonyl compound. This is actual mechanism of acyloin molecule formation, and that's why this reaction is called as a Acyloin condensation reaction, where there are some many examples are for this reaction. So first one, this is what intramolecular type of the reaction, where both the esters are present in the same. Okay, like Deichmann condensation reaction, formation of cyclic product. But here in this case what, this is an ester, diester will be used here in the presence of sodium, and toluene or aromatic hydrocarbons as a solvent, and water, there will be a formation of what, alpha hydroxy cyclohexanone. Second example is what, ester is given in the presence of sodium and xylene along with the TMSCl. What is the TMSCl? The reaction is given here. TMSCl is a trimethyl silyl chloride, and whatever the vinyl diols are formed, that will be protected, that OH will be protected by TMSCl and undergo the cleavage in the presence of a small weaker nucleophile, and will form a product that is called alpha hydroxy ketone. So this is a modified type of what reaction. Another example is also be given. You can make this mechanism of these reactions, and this is one of the beautiful transformation of an two ester molecules to into the what, the alpha hydroxy compound, that is alpha hydroxy carbonate. So that's called as a Acyloin molecule. So this is the first named reaction, that is letter A, and named as a Acyloin condensation. So stay connected, stay safe. Thank you for watching this lecture. So if you are satisfied with this content, like, share and subscribe, and don't miss a bell icon for more updates. Thank you.